Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about multiplying radicals with the same indices. So without further ado, let's do this topic. So we do have 13 examples class for you to really understand how to multiply radicals, and we will be answering this one step by step. Alright, so let's start. Now in multiplying radicals class, it says that the nth root of A multiplied by the nth root of B, your answer will be the nth root of A times B. So if they have the same indices, simply copy the index and then multiply the radical. So multiply the equation inside the radical symbol. Multiply A and B. Alright, so let's try number 1. So the square root of 3 multiplied by the square root of 2. Now, once again, before multiplying the radicals class, you always check if you can simplify the radical. So, can we simplify square root of 3 and square root of 2? Because if not, you can just simply multiply the radicals class. Okay, the square root of 3 multiplied by the square root of 2, since we cannot simplify square root of 3, and we cannot also simplify square root of 2, so just simply multiply class. So, the square root of 3 times 2, that is 6. So that's the answer class. You check first your answer if you can simplify. Can we simplify square root of 6? Nope, we cannot simplify square root of 6. So that would be our final answer for number 1, square root of 6. That's it class. That's the answer for number 1. Easy, right? Simply copy the square root. So they have the same index. That would be 2. Always remember class that in every square root the index is 2. So copy the index and then multiply 3 times 2, that is 6. So you can put 2 here, or that's okay. Understood that the index there is 2. That's the answer class for number 1. Alright, let's try number 2. Square root of 9 times square root of 4. So can we simplify square root of 9? What would be the square root of 9 class? You think of a number that when you multiply it by itself, the answer is 9. That's correct. The square root of 9, that is 3, times the square root of 4, that is 2, right? 2 times 2, that is 4. So the square root of 4, that is 2. And 3 times 2, that is 6. So therefore, the answer for number 2, that's equals to 6. Alright, so the answer is 6. So you can also do it this way. Square root of 9 times square root of 4, that's square root of 36. And the square root of 36, that is 6. So once again, class, if you can simplify, you simplify it first before answering. So let's have number 3. 4 square root of 3 times 3 square root of 3. So if you have example like this, you multiply first the numbers outside. So 4 times 3. So multiply this one first. 4 times 3, that is 12. Then you multiply the radicals class. Square root of 3 times square root of 3, that is square root of 9. So can we simplify square root of 9? Yep, we can simplify square root of 9. So the square root of 9, that is 3. You put it outside the radical symbol. Once again, the square root of 9, that is 3. You put it outside the radical symbol, then you multiply it by 12. So this will be 12 times 3. So, sir, where did you get 3? 3 class came from the square root of 9. So, square root of 9, that is 3. You multiply it by 12. Once again, class, do not add 12 and 3. It should be multiplication. 12 times 3. 3 came from the square root of 9. Square root of 9, that is 3. 3 times 12, that is, the answer is 36. This is the answer class for number 3, 36. Let's try number 4. So once again, if you can simplify, you always simplify. So 3 times square root of 12 multiplied by 2 square root of 18. So if you multiply directly class 12 and 18, these are large numbers, right? 12 times 18, that would be a large number. So the thing that we will do is we need to simplify this one first before multiplying. Can we simplify square root of 12? Yup, we can simplify square root of 12. You find two numbers that when you multiply the two numbers, you will get 12. One number is a perfect square, the other is not. What are those perfect square class? So we have 4, we have 9, 16, 25, 36, 49, 64, 81, and so on, right? So we call these numbers perfect squares because when we get the square root of this particular number, our answer is a whole number, right? Example class, the square root of 4. What's the square root of 4? That's correct. The square root of 4, that is 2. Because 2 times 2, that is 4. The square root of 9, that is 3. Because 3 times 3, that is 9. Square root of 16, that is 4. And so on. So these are perfect squares. So to simplify square root of 12, you find two numbers. That one number is a perfect square, the other is not. That when you multiply the two numbers, you will get 12. Of course, we can simplify this one by 4 times 3, right? So copy 3, and then for square root of 12, we can simplify that one by 4 times 3. Because 4 is a perfect square, so 4 is a perfect square, 3 is not. That when you multiply, you will get 12. Times, so copy 2. Now for square root of 18 class, what would be that number? One number is a perfect square, the other is not. That when we multiply, we will get 18. That's correct. That would be 9 times 2, right? Because 9 is a perfect square, then 2 is not. So we can see 9 here in the perfect square. 9 times 2, that is 18. 9 is a perfect square, then 2 is not. That's how you multiply, class. You find two numbers. One number is a perfect square, the other is not. So this will be, copy 3. The square root of 4, that is 2. So you put it outside the radical symbol. You multiply it by 3. Once again, the square root of 4, that is 2. You put it outside. So this will be 3 times 2. Then simply copy square root of 3. We cannot simplify square root of 3. So simply copy square root of 3. Times, so copy 2. Then the square root of 9, that is 3. Put it outside the radical symbol. Square root of 9, that is 3. You multiply it by 2. So 2 times 3. Then copy square root of 2 because we cannot simplify square root of 2. And this will be 3 times 2, that is 6. Copy square root of 3 times 2 times 3, that is 6. Copy square root of 2. Alright, so it's easy for us, class, to multiply this one. So 6 times 6. So 6 times 6, that is 36. Then square root of 3 times square root of 2, that would be square root of 6. Can we simplify square root of 6? Nope. We cannot simplify square root of 6. So this will be our final answer, class. Once again, 6 times 6 is 36. Square root of 3 times square root of 2, that's square root of 6. That's it, class. That's the answer there for number 4. 36 square root of 6. Alright, let's try number 5. So 3 square root of 5 times 2 square root of 6. So, can we simplify square root of 5 and square root of 6? Nope. We cannot simplify square root of 5 and we cannot simplify square root of 6. So, just simply multiply 3 times 2, that is 6. 5, square root of 5 times square root of 6, that would be square root of 30. So, once again, multiply the numbers outside the radical symbol. 3 times 2, that is 6. Square root of 5 times square root of 6, that would be square root of 30. Can we simplify square root of 30? You find two numbers. One number is a perfect square, the other is not. That when you multiply, you will get 30. Nope, there is none. So this will be our final answer for number 5. So that would be 6 square root of 30. For number 6, class, we do have two solutions for this one. And I will be explaining the two solutions, class, for you to answer this one easily. We do have some shortcuts for number 6, class. If you have large numbers, we can do shortcuts. So we will explain the long method first. So square root of 15 times square root of 10. So you can just simply multiply. So copy the index, square root. Same index, that is 2. Copy the index, that is 2. So square root of 15 times square root of 10, that would be square root of 150. Alright, so can we simplify square root of 150? You find two numbers. That when you multiply the two numbers, you will get 150. One number is a perfect square, the other is not. So we can simplify this one by, we can divide 150 by 25, right? Okay, so 25 is a perfect square. So therefore, we can simplify this one by 25 times 6, right? Because 25 times 2, that is 50. 25 times 4, that's 100. 25 times 6, that's 150. And then, 25 times 6, that is 150. The square root of 25, that is 5. You put it outside the radical symbol. Square root of 25, that is 5. Then simply copy square root of 6. We cannot simplify square root of 6, so simply copy square root of 6. So this will be our answer, class. So in shortcut, class, square root of 15 times square root of 10. So you can do shortcut class. Because if these are large numbers class, example class for number 7. Example number 7, square root of 35 multiplied by square root of 10. Of course, your answer will be square root of 350, right? 35 times 10, that's 350. And you are told to find two numbers that when you multiply the two numbers, you will get 350. One number is a perfect square, the other is not. So it will take time class because these are large numbers. So the thing that we will do in shortcut, you find two factors of 15 that one factor is common to 10. Okay, once again, you find two factors of 15 that one factor is common to 10. So for 15, we can simplify this one by square root of 5 times square root of 3, right? Square root of 5 times square root of 3, that's square root of 15. And for 10 times, we can simplify this one by square root of 5 times square root of 2, right? Square root of 5 times square root of 2, that's square root of 10. Square root of 5 times square root of 3, that's square root of 15. So the thing that you will do, class, you find two factors of 15 that one factor is common to 10. So as you can see, class, they have common factors, which is 5. So 5 times 3, that's 15. Square root of 5 times square root of 2, that's square root of 10. So the common factor, that is square root of 5. And then when you multiply this one, square root of 5 times square root of 5, that's square root of 25. Square root of 3 times square root of 2, that would be square root of 6. And the square root of 25, what would be the square root of 25, class? That's correct. The square root of 25, that is 5. Then copy square root of 6. You will get the same answer, class, for this one. So you can have this solution, class, or you can have this one. So it depends on you which do you prefer, but for me, class, it's better to have this one because I can just simply cancel 5. So if I have the same factor, which is 5, I can just simply cancel 5, then put 5 here, then square root of 3 times square root of 2, that's square root of 6. Now, why did you cancel 5, sir? Because square root of 5 times square root of 5, that's square root of 25, and the square root of 25, that is 5. Then simply copy square root of 6. Now, if it's hard for you to understand this one, do not be worried, class, because we will have another example for number 7. Okay, let's have an example, class, for number 7. This one, square root of 35 times square root of 10. So let's have this one, class. So let's have number 7, class, for you to really understand the shortcut for that. If you have large numbers, you can do that one. So number 7, square root of 35 times square root of 10. Once again, in the long method, you just simply multiply the radicand. So 35 times 10, that would be square root of 35 times square root of 10. That's square root of 350. So it will take time, class. You find factors of 350. One number is a perfect square. The other is not. That when you multiply, you will get 350. Of course, we can simplify this one by, I think, 25 times 14, right? Let me check that one. 25 times 14. 4 times 5, that is 20. 0 carry 2. 4 times 2 is 8. Plus 2, that's 10. 1 times 5 is 5. 1 times 2 is 2. So 0, add. 0 plus 5 is 5. 1 plus 2 is 3. 350. So we can simplify this one by the square root of 25 times 14. Alright, so square root of 25 times 14. One number is a perfect square. The other is not. So 25 times 14, that's 350. And then we can simplify 25. The square root of 25, that is 5. Then simply copy square root of 14. We cannot simplify square root of 14. So that's the answer there, class, in the long method. But once again, class, it will take time if you do it that way. So the thing that we will do, class, is we need to do the shortcut way. So you find two factors of 35 that one factor is common to 10. Of course, we can use 5, right? Because 35, we can divide it by 5, and also 10. We can divide 10 by 5. So we can simplify this one by the square root of 5 times the square root of 7, right? Square root of 5 times square root of 7, that is square root of 35. Times, and for 10, we can simplify this one by square root of 5 times square root of 2. So one factor is common for 35, and 10, that is 5. So 5 times 7, that's 35. 5 times 2, that is 10. So we can simplify this one by square root of 5 times square root of 5. That's square root of 25. Square root of 7 times square root of 2. That's square root of 14. And the square root of 25, that is 5. copy square root of 14. So same answer class for me. It's better to have this solution. If the numbers are large class, you find two factors. One factor is common to this particular numbers. So that's the thing that you will do. For me class is square root of 5 times square root of 7 times square root of 5 times square root of 2. I will just simply cancel this out. Cancel the radical symbol, then simply copy 5. Copy 5, then square root of 7 times square root of 2, that's square root of 14. Now, sir, why did you copy 5? Because square root of 5 times square root of 5, that's square root of 25. And the square root of 25, that is 5. So, that's the thing there, class, that I will do if the numbers are large numbers. So, if you understand this one, better for you, class, because you can just simplify the radicals or you can just simply multiply the radicals in an easy way. So, let's have number 8. So I hope you got that one, class. If not, you can always message me, class, in our Facebook channel. Same name with our YouTube channel. Alright, the cube root of 3 multiplied by the cube root of 9. So once again, same index. So the cube root of 3 times 9, that is 27. So copy the index 3, then 3 times 9, that is 27. Do we have the cube root of 27? You find a number, class, that when you multiply it by itself 3 times, you will get 27. Do we have? Yep, the cube root of 27, that is 3. Because 3 times 3 times 3, that is 27. Alright, so this will be our answer for number 8, 3. Let's have number 9. So the cube root of 4 times the cube root of 4. So the cube root of 4 multiplied by the cube root of 4. So copy the index, copy cube root. So this will be the cube root of 4 times 4, that is 16. The cube root of 16. So can we simplify the cube root of 16? Yep, we can simplify the cube root of 16. You find two numbers that when you multiply the two numbers, you will get 16. One number is a perfect cube, the other is not. Okay, so what are those perfect cube? We have 8, because 2 times 2 times 2, that is 8. 2 raised to the power of 3, that is 8. 2 times 2 times 2, that is 8. So 8 is a perfect cube. The cube root of 8, that is 2. We have 3 cube. So 3 times 3 times 3, that is 27. 4 cube, 4 times 4 times 4, that is 64, and so on, right? So for 16, class, we can simplify this one. One number is a perfect cube, the other is not. That when you multiply, you will get 16. So we can simplify this one by the cube root of 8 times 2, right? Why is that, sir? Because 8 times 2, that is 16. 8 is a perfect cube, 2 is not. So once again, class, you find two numbers. One number is a perfect cube, the other is not. That when you multiply, you will get 16. Of course, that would be 8 times 2, right? Because 8 is a perfect cube, 2 is not. And the cube root of 8, that is 2. You put it outside the radical symbol, the cube root of 8, that is 2. Then simply copy cube root of 2. That's it, class. This will be our answer for number 9. 2 cube root of 2, because the cube root of 8, that is 2. You put it outside the radical symbol, and then copy cube root of 2. That's it, class. That's the answer for number 9. So let's try number 10. So I hope you're still with me. If you have some questions, class, please do leave a comment in the comment section down below. Alright, let's have number 10. So 2 square root of 3, quantity 2 square root of 3 plus 4 square root of 3. So the thing that we will do, class, is we just need to do the distributive property. So multiply this one, 2 square root of 3 times 2 square root of 3. So this will be 2 times 2, that is 4. Square root of 3 times square root of 3, that's square root of 9. Can we simplify square root of 9? Yep. Square root of 9, that is 3. So this will be 4. The square root of 9, that is 3. You put it outside the radical symbol. So this will be 4 times 3, that is 12. So 2 square root of 3 times 2 square root of 3, that is 12. So 12 plus, so this one, simplify this one, multiply 2 square root of 3 times 4 square root of 3. So this will be 2 times 4, that is 8. Square root of 3 times square root of 3, that's square root of 9. So copy 8. So square root of 9, that is 3. You put it outside, then you multiply it by 8. So this will be 8 times 3, that is 24. So 12 plus 24, that is 36. So this is the answer, class, for number 10, 36. Alright, let's try number 11. So 11 square root of a multiplied by the square root of a cubed minus 7. So once again, distribute. So this will be a square root of a times square root of a cubed. So this will be a times a cubed. So this will be square root of a times square root of a cubed. That would be square root of a raised to the power of 4. Once again, class, square root of a times square root of a cubed. That would be square root of a raised to the power of 4. Now, why is that, sir? Because a times a cubed. So in the laws of exponent, you still remember, if they have the same base, simply copy the base, then you will add the exponent. 1 plus 3, that is 4. 1 plus 3, this will be a raised to the power of 4. So that's why you have square root of a raised to the power of 4. So can we simplify square root of a raised to the power of 4? Yup. We can simplify this one by a squared, right? Because we can divide 4 by the index. So understood that the index there is 2. 4 divided by 2, that would be a squared. So the square root of a raised to the power of 4, that is a squared. Because if you write this one in exponential form, this will be a. Okay, a, then 4 will be the numerator of the fractional exponent. Then 2 will be the denominator. And 4 divided by 2, that is 2. So a squared. So the square root of a raised to the power of 4, that is a squared. So this will be a squared. Then square root of a times negative 7. So simply copy. So once again, class, do not multiply negative 7 inside a. It should be the number outside. Understood that there's 1 here. So negative 7 times 1, that's negative 7. Simply copy square root of a. Minus 7 square root of a. That's it, class. This is the answer for number 11. Alright, so pause the video, class. We're down to the last 2 of our example. So I hope you understand this one, class. So down to the last 2 of our example. Alright, so for number 12, we have square root of 3x squared y raised to the power of 5 times square root of 6x raised to the power of 5, then y. So this will be square root of 3 times square root of 6. That would be square root of 18. Now for x, class, simply copy the base. Then you will add the exponent. 2 plus 5, that is 7. Once again, class, x squared times x raised to the power of 5. If they have the same base, simply copy the base. Then you will add the exponent. 2 plus 5. So this will be x raised to the power of 7. I hope you remember this one, class, and the laws of exponent. In multiplying same base, simply copy the base, then you will add the exponent. 2 plus 5, that is 7. Alright, and then for y, so we have y raised to the power of 5 times y. So understood that there's 1 here. This will be y raised to the power of 5 plus 1. This will be y raised to the power of 6. Y raised to the power of 6. Alright, and the next step is we need to factor this out. So we need to simplify. For 18, class, do we have square root of 18? Nope, we don't have square root of 18. But we can simplify square root of 18. You find a number. One number is a perfect square, the other is not. That when you multiply, you will get 18. Of course, that would be 9 times 2, right? 9 is a perfect square, then 2 is not. Okay, 9 is perfect square, then 2 is not. When you multiply, you will get 18. Now, for x raised to the power of 7, you factor this out, class, that one factor can be divided by the index. Okay? It should be the greatest factor near to 7 that can be divided by the index. So, this will be x raised to the power of 6 times x raised to the power of 1. Now, you'll be asking a question, sir, why do we need to have x raised to the power of 6? We can use x raised to the power of 2. We can use x raised to the power of 4, right? Because 2, understood that there's 2 here, we can divide 2 by 2. We can also divide 4 by 2. But we need to select, class, the greatest factor that is near to 7 that we can divide it by 2. And we select 6. Now for y raised to the power of 6, can we divide 6 by 2? Yep, we can divide 6 by 2. So therefore, our final answer will be the square root of 9, that is 3. You put it outside the radical symbol. So for square root of 2, we don't have square root of 2, so therefore 2 will remain inside the radical symbol. Now for this x raised to the power of 6, we can divide 6 by 2. Understood that there's 2 here. 6 divided by 2, that is 3. So we can put it outside the radical symbol. 6 divided by 2, that is 3. So we have x cubed. For x raised to the power of 1, we cannot divide 1 by 2. So x will remain inside the radical symbol. For y raised to the power of 6, we can divide 6 by 2. So we have y raised to the power of 3. You put it outside the radical symbol, class, since we can divide 6 by 2. And the copy square root of 2 will remain as well as x. That's it, class. This will be our answer for number 12. Alright, so last one, class, number 13. So you pause the video. I will be erasing this one. Let's have number 13, last one. So 13, we have the cube root of 9xy squared times 5 cube root of 3x raised to the power of 4 y raised to the power of 6. Alright, so multiply the numbers outside. So we have 5, and then understood that there's 1 here. If you didn't see any number outside the cube root, understood that there's 1. So 1 times 5, that is 5. Copy cube root of 9 times 3, that is 27. For x, copy x. Then you add the exponent. Understood that there's 1 here. 1 plus 4, that is 5. For y, copy y. Then you add the exponent. 2 plus 6, that is 8. Alright, and this will be 5 cube root of... So, do we have cube root of 27? Yep, we have cube root of 27. That is 3, right? So, later on, we put it outside the radical symbol. So, let's copy first 27. Let's factor this out first. Now, for x raised to the power of 5, we can factor this out by x raised to the power of 3 times x raised to the power of 2, right? Since we cannot divide 5 by 3, 5 divided by 3, that cannot be. So, we need to factor this out. 1 factor, we can divide it by 3. So, that would be x cubed. So, we find the least number. Okay, least number, that is the greatest number near to 5, and we have 3. Because we can divide 3 by 3. And then, for y raised to the power of 8, so we select y raised to the power of 6, right? We can factor this out by y raised to the power of 6. Then y raised to the power of 2. Now, once again, you will be asking questions, sir, why do we need to select y raised to the power of 6? Because 6 is divisible by 3. We can divide 6 by 3. We cannot use class y raised to the power of 7 because we cannot divide 7 by 3. So, we select y raised to the power of 6. Because we can divide 6 by 3. And 6 plus 2, this will be y raised to the power of 8. Alright, I hope you get this one, class. If not, you can always see my video class in simplifying radicals. You can have this one, class, in simplifying radicals. So, this will be copy 5. Then the cube root of 27, that is 3. Because 3 times 3 times 3, that is 27. So, the cube root of 27, that is 3. You put it outside radical symbol. You multiply it by 5. Okay, 5 times 3. Then, for this one, 3 divided by 3, that is 1. So, you put it outside the radical symbol. So, we still have x. So, copy x. Then, for x raised to the power of 2, we cannot simplify this one. Okay, we cannot divide 2 by 3. So, x raised to the power of 2 will remain inside the radical symbol. For y raised to the power of 6, we can divide 6 by 3. 6 divided by 3, that is 2. So, 6 divided by 3, that is 2. We put it outside the radical symbol. So, that would be y squared. Because 6 divided by 3, that is 2. Y squared. Then for 2, we cannot divide 2 by 3. So, the remaining equation on the radical symbol, that would be x squared, then y squared. Alright, and our final answer will be, so 5 times 3, that is 15. Then copy x, then copy y squared. And do not forget, class, the cube root. So, always be careful with this one. So, do not forget the cube root here, the index 3. So, that would be the cube root of, so copy x squared, then y squared. That's it, class. This is the answer for number 13. So, I hope this video helps. Now, once again, if you like this video, do not forget to like, share, and subscribe. You share to your friends and to your classmates so that we can help more students, especially to those students who are really struggling in solving math problems. Once again, class, the next part of our video will be multiplying radicals with different indices. So once again, this is Teacher MJ. Have a great day, class. Goodbye for now. Bye-bye.